In this video, we're going to evaluate this integral given here using partial fraction decomposition. And I'll let you know that this is in lowest terms. Degree of the numerator is 3. Degree of the denominator is 4. Got an x squared and x squared here at the bottom. Satisfies the conditions. Now you could confirm that it is in lowest terms by making sure that x minus 3 and x plus 3 do not divide the numerator. But just to make it easier here, I'll tell you that it is in lowest terms. So all we have to do here is continue with the process of partial fraction decomposition. Again, the x squared minus 9 is not completely factored out. That would be x minus 3, x plus 3. So those are linear factors. So we would have something like this here. X squared minus 9 factors into x minus 3 and x plus 3. So that's what we have. One linear factor, so that would be a constant a over x minus 3. Another linear factor, x plus 3. Then we have a constant b in the numerator. And then the second factor is an irreducible quadratic, doesn't factor into real values. So that takes the form cx plus d over x squared plus 4. And then the next process then goes through and to find the constants, the values of a, b, c, and d. So what we're going to do is write it this way without the integrals and find the values of a, b, c, and d. I'm going to multiply through by the LCD, which is x squared minus 9, or x minus 3 times x plus 3 and x squared plus 4. If I do that, I'm left with the numerator on the left side. And then on the first term here, the x minus 3 would cancel. And I would be left with x plus 3 times x squared plus 4. Do the basic algebra there. And this is what it looks like. Multiplying both sides by least common denominator. This is what it winds up with. Now we could set up a system of equations, but you can treat this as an identity and just plug in numbers and get values for a, b, c, and d by getting equations. So here's the way it works. In the first one here, I pick x to be 3. Now why did I pick x to be 3? Because if I put 3 here where I have the b, 3 minus 3 is 0. So that gets wiped out. Plugging in 3 here, this goes to 0. Plugging 3 here where the x squared minus 9 is, that gives me 9 minus 9. That gets wiped out, 0. All I'm left with is this. So what is that? 3 and 3 is 6 there. 3 squared is 9 and 4 is 13. So 6 times 13 is 78. That's A. And then if I plug in 3 over here, that gives me 78. Now you can do that manually, or you can do it with your calculator. So let me just show you what I have here. I have it entered here at this graphing calculator. And then I'm going to go to second, trace, enter, access the calculate menu. I want the value of that expression on the left side, that minus x cubed plus 10x and so on, when x is equal to 3. So I want the value, enter 1 over here, and I want the value at 3. Plug in 3, hit enter, and there it is, 78. So if I plug in 3 here where the x is on the left side, minus 3 cubed plus 10, 3 squared minus 4 times 3 plus 27, I get 78. That's how I got this solved. Now on the second one, I let x to be negative 3. Let me cancel this out here. Pick x to be negative 3. And again, negative 3 because negative 3 for this one here cancels that out to 0. And negative 3 over here, negative 3 squared is 9 minus 9. This goes to 0. So that's just easier with this right here. So I got b there, and then a negative 3 here, and negative 3 here, so that's negative 6. And the negative 3 here is squared. That's 9 and 4 is 13. Negative 6 times 13 gives me this part right here. And remember the other 2 are 0. So I get negative 78 is equal to, and then I get this negative 3 using the calculator. What's the value of the expression over here on the left side at negative 3? Well, it's 156. So that gives me 156 equal to negative 78b. Divide both sides by negative 78 here. This cancels out, and I get b is equal to negative 2. Now for the next one, I pick x to be 0. So notice if I pick 0, on the replace the x by 0 on the left side, that goes to 0, that goes to 0, that goes to 0, and I get 27 here. And then I put a 0 here where the x is. I got a. Remember, a is 1, so that's a 1. And then 0 and 3 is 3. 0 squared is 0, that's 4. So that's 3 times 4, that's 12. That's how I get this part right here. Remember here, b is negative, that's what I got here. And then put a 0 here and a 0 here, that's negative 3 times 4. That's a negative 12. So I got this here. This then is 24, and 12 is 36. And then here I got 0 here, 0 here for the x's. That gives me negative 9d. Solve this equation for d. I get d is equal to 1. And then finally, to get the c, again, use the fact that you know a to be 1 and b to be negative 2. And you plug it in over here, doing the same thing we did. C will be 0. So now we have those constants. A is 1, B is negative 2, and D is equal to 1. Well, that's really the hard part for this problem. So now we can go to and finish the integration. So for the first integral, A was 1, so this will be 1 over x minus 3 dx plus integral B, we got negative 2. This will be negative 2 over x plus 3 dx plus integral C was 0, so this x term cancels here. D was 1, so I get 1 over x squared plus 4 dx. This one here and this one here are fairly easy to integrate. Basic u substitution, and you don't need to have to use it. You don't really have to use it because the derivative of x minus 3 is 1. The derivative of x plus 3 is 1. So this would be like a u here and a du here, u here and a du here. So I just go up here and say this is going to be the integral of natural log, absolute value. This would be x minus 3. So natural log of x minus 3 is the integral for the first one. The second one here, integral of minus 2 over x plus 3 dx, is similar. The only difference is it has a constant here. It's not a 1, so you just bring out the constant outside. And that same procedure applies. This is going to be natural log of the absolute value of x plus 3. And then the last one, we'll simply use the formula that actually I derived in an earlier video to work another problem in that same video. And this one told us it's the integral of du over a squared plus u squared was equal to 1 over a. A is a constant. Arctangent, or I can use tangent inverse of u over a. Now in our case, the u would be x and the a would be 2. So this would be plus 1 over a, so it'd be 1 over 2. Arctangent or tangent inverse, either one, of u over a. Again, in our case, the u is x, the a is 2. And then it's plus the constant of integration. And that's your answer. Thanks for watching. We'll see you next time.